This is Unit 4, Similarity. Preview video 4.1, Proportions and Similarity. Take a moment, sit tall at home. Ready? Take a deep breath in. Hold your breath. And exhale. All right, so similarity. It's a concept you're constantly surrounded by. Anytime you cook, any kind of mechanics, drawing, all of this involves similarity. Cleaning solutions, baking, all of it involves similarity. I'll explain in just a moment. Clothes shopping involves similarity. Don't forget a date, time, and location, as well as a parental sign out. There's 4 things we're going to be doing today. 4 things. First off, you're going to explain the difference between a ratio and a proportion. They're related, but not the same. You're going to accurately solve proportions, where the key to multiplying is not multiplying, but factoring. You're going to understand the impact of differing units on ratios. You're going to define similarity and use it to set up and solve proportions. We're going to explain the difference between a ratio and versus a proportion. They're similar, but not the same. Definition of a ratio. It is a comparison of 2 items by division. A comparison of 2 items by division. When you're working with units and ratios, units such as centimeters, meters, feet, yards, you must get in the same unit before you can make a ratio. The minute I say units, you need to find this page in your reference booklet. It's towards the beginning, and it's all the unit conversion chart. I expect you to have that memorized. The different conversions of centimeters, centimeters squared, centimeters cubed, inches, inches squared, inches cubed, yards, yards squared, yards cubed. So it's important you have those different ratios memorized. So if you're still like, what's a ratio? How is it division? You see these all the time. There's 4 styles of ratios you need to be familiar with. Watch carefully. So if we say 3:2:4, it's a 3:4 ratio, or 3:2:4 using a colon. 3/4 is the same ratio, or 3/4 is how fractions are often expressed. Keep in mind, all decimals are ratios. 3/4 of a dollar, 75 cents. So all 4 of these, 3:4 with the word 2, colon, fraction, decimal, every single one of these is a ratio. It's a comparison of items by division. Now, knowing that all fractions are ratios, if I have an equation of fractions, for example, I have 2/4, which reduces equals to 1/2. The red is a ratio. The equation of ratios is a proportion. So taking this example, 2/4 reducing to 1/2, if you order the terms from least to greatest, so the least is 1, and then the next would be the 2 and the 2, and the last is the 4. We would call the beginning and end terms called the extremes, and the two middle terms, whatever they are, we call those the means. Now, if you're taking a look at this, the means, the extremes. So you notice the product of the means is the same as the product of the extremes. You guys know this as the cross multiplication property. That's how you know if it's a proportion. A true proportion is the product of the means equals the product of the extremes. You're going to accurately solve proportions by cross multiplying, where the key to multiplying is not multiplying, but factoring. This is a trick you can use. There'll be times that you'll be forbidden from using a calculator. It's like, how do you solve 2-digit multiplication if you can't use a calculator? The key to multiplying is not to multiply, but to factor. Let me show you this technique. It'll save you a lot of time. So if I were to solve for k here, I would cross multiply 15 and k equals, and then I go like this, 35 times 33. Now, if I left you, most of you to your druthers, you'd be getting a calculator out, 35 times 33. Stop it. The key to multiplying is not to multiply. It's to factor. So I'm not going to continue multiplying. Instead, watch what I do. I'm going to divide out this 15. Now watch, we're going to factor. It doesn't matter which way I start the factoring. I'm going to start this way. So I factor, I know 5 goes into both. So I cross that out, cross that out. 5 goes into 15 3 times. 5 goes into 35 7 times. Now I factor this. 3 goes into 33 11 times. You just finish multiplying. K equals 7 times 11, 77. You've heard of, look, Mom, no hands. Well, look, Mom, no calculator. You can do this. Let's do it again over here. Some of you are like, what is this magic? Watch the magic again. Cross multiply. Why did I not write 144? Because the key to multiplying is not multiplying. It's factoring. Simply divide by 2. Doesn't matter if I take the 2 into the 10 or the 2 into the 14. I'm going to take the 2 into the 14, and we get 70 equals P. Something else you need to be familiar with is how to convert words into ratios. says two supplementary angles have a ratio of 2 to 3. Find the measure of the angles. Couple tricks here. First, you need to remember what supplementary means. Supplementary means adds up to 180. So I have two angles that add up to 180. They have a ratio of 2 to 3. Now that does not mean 2 and 3, the number. That's 2 of something and 3 of something. It's a ratio. So to solve, it would be 3x plus 2x equals 180. Of course, x equals 36. So this would be 72, and this would be 108. How do I know it's a ratio? If I do 72 and 108, and I divide both by 36, I get a ratio of 2 to 3. There's my check. And they add up to 180. You do this page. Cross multiply. You may not touch a calculator. Pause. Welcome back. Get out your red pens, folks. Red pens. I should see this page corrected in red pens. Star smiley if you're correct. I'm going to go fast. I'm not going to explain because you already have done it and you're just correcting your work. So you should have gotten 5 and 39. Hopefully you did that without touching a calculator. Complementary angles means they add up to 90. They have a ratio of 4 to 1, so that's 4 of something and 1 of something. So it is 4 of something plus something equals 90. 5 of something equals 90. Divide by 5, and x equals 18. So that means this is 18. 4 times 18. Of course, we get 72. All right, the next thing we need to watch out for is understanding how differing units have on ratios. You have to watch out for units. Billions of dollars can be wasted if you don't keep track of units. We're going to do an example of this in class. Remember, a ratio is a comparison of two values by division. But when we say values or items, they must be in the same unit. I'm going to do a couple examples here with you. I'd really like you to put your finger right there where it says Trish, finger, and you're going to read out loud with me. Please read. Ready? Read. Trish needed 3 feet of Velcro for every 2 yards of fabric purchased to make a table banner. What is the ratio of Velcro needed compared to the amount of fabric? Okay, so what's going on is that Trish is buying strips of Velcro in order to Velcro a fabric table runner. It says the ratio is 3 feet of Velcro for every 2 yards. What is the ratio? Here's the most common mistake. Students just do this. They see a 3 and a 2, and they say, oh, the ratio of Velcro is 3. The ratio of fabric is 2. Therefore, the ratio of Velcro to fabric is 3 to 2. Ta-da! Wrong. Be very careful with this. It's 3 feet of Velcro, 3 feet Velcro to 2 yards of fabric. You cannot do a ratio until it's in the same unit. In the first dimension, 1 yard, notice I specifically said first dimension, which is just length. There is 3 feet to 1 yard. So 2 yards means I have 6 feet. And the Velcro, I have 3 feet. Now that I have the same units, I can reduce. So the ratio of Velcro to fabric is a 1:2 ratio of Velcro to fabric. That is incorrect. That is correct. Let's read. Finger on paper. Ready? Out loud. Read. An industrial-sized recipe to make 300 chocolate chip cookies calls for 800 grams of sugar for every 2.5 kilograms of flour. What is the ratio of sugar to flour? Once again, this is the most common mistake students make, is they see 800 and 2.5, and they think the ratio of sugar to flour is 800 to 2.5. That would be incorrect. So sugar to flour. Sugar is 800 grams of sugar to 2.5 kilograms of flour. Kilo means 1,000. Kilograms is 1,000 grams. So we have 800 grams. We're going to move this to the right as if we're timesing by 1,000, which means you bunny hop 3 times. 1, 2, 3. So 2.5 kilograms is 2,500 grams. Now that we have the same ratio, we reduce. I can reduce by 2 zeros. So I have 8 to 25. I can't reduce any farther. So my final ratio, for every 8 parts of sugar, I need 25 parts of flour. That is your ratio. This page you're doing on your own. Pause the video. All right, friends, red pens. I'm going to be checking for corrections. So taking a look here, we're going to write the ratio 44 centimeters and 2 meters. Here's the most common mistake, 44 to 2. Oh, looky here. 2 goes in there 22 times to 1, and this would be incorrect. So it's 44 cm to 2 meters. In 1 meter, there's 100 centimeters. Centi, same prefix as century. So we have 44 centimeters to 200 centimeters. Obviously, we're going to divide both by 4. So dividing by 4, and you should have gotten 11 to 50 is your ratio of 44 centimeters to 2 meters. Harley-Davidson wheel travels 82 inches. Okay, 82 inches for each complete roll. So when that tire rolls, all the way around, it goes 82 inches. What is the ratio of tire rolls for a mile? Expressed in whole numbers. This takes a double conversion. And the reason is this is in inches, this is in miles. Looking again on that units page, you know there's 5,280 feet per mile, but in every foot there is 12 inches. So to get a mile into inches, you're doing 5280 times 12. Yes, we're doing this longhand, folks. So there is 63,360 inches in a mile, per mile. And we're dividing that by 82 inches. 63,360 inches in a single mile. We're dividing it by 82 inches. Now I'm getting lazy. That's 773 approximately. No, something's wrong. That's not right. 63360. There we are. Divided by 82. That's okay. So it is turning 773 times. So that ratio is approximately 777 turns per 1 mile. So you have to watch out for units when you're dealing with ratios. Last but not least, how does all of this fit into our concept of similarity? We're going to define similarity and use it to set up and solve proportions. You are surrounded by similarity, literally surrounded by it. Every time you go clothes shopping, you are dealing with similarity. Shoes shopping, anything where you have multiple sizes of the same item, that involves similarity. Basic definition of similarity. If you have small, medium, large t-shirts, they're all the same shape shirt, but different sizes. This is the definition, slang, of similarity. Items which have the same shape, but a different size. And the symbol we use for similarity looks like a Spanish tilde, or half a congruent sign, if you will. That means similar, same shape, different size. That's the slang version. Here's the geometric technical version. It's called scare. Definition of scare. Similar shapes have congruent angles, ratios equal. Similar shapes have congruent angles, ratios equal. Similar shapes have congruent angles and ratios which are equal. Ratios equal means you have a proportion. So the rest of this unit, all 3 lessons, 90% of what you're going to be doing is cross-multiplying and solving proportions. This is how you test for similarity. Let's take a look here. First off, we're going to test for CA, congruent angles. Notice all the corresponding angles are congruent. Now we check our side ratios. 4 to 24. That is a 1 to 6 ratio. 8 to 48. That's also a 1 to 6 ratio. So notice that the ratios are equal all the way around and the angles are congruent. That means these 2 rectangles are similar. Now, when things are similar, you can watch out for a scale factor. Scale factor is the ratio of the sides simplified. The ratio of the sides simplified. So usually scale factors are expressed as a fraction, sometimes using a ratio and a colon. Ratio of the sides simplified. So this is how you check for scale factor. The smallest side here, we're going to reduce. 5 goes in there twice, 5 goes in there 3 times. The medium side here, 7 goes in there twice, 7 goes into 3 times. So the scale factor of these similar shapes is a 2 to 3 ratio. First, we're going to determine if something is similar using scale. Step number 1, we check to see if we have congruent angles. Notice the parallel lines. Parallel lines means these 2 angles have to add up to 180. So this is 100, that's 80. If that's 100, this is 80. And because it's parallel, you can see it's rotated. So congruent angles, check. Yes. Now, let's check the sides. 7 to 14, 1 to 2, 7 to 14, 1 to 2. It is 1 to 2 all the way around. Ratios equal, check. These items are similar. Let's check these ones, congruent angles. So these are congruent to these, they match. These are congruent to these, they match. Check, congruent angles. Let's check the ratio. Long side to long side. 8 goes into both. It's a 2 to 3 ratio. Short side, short side. What goes into both? 4. 4 goes in here 3 times, 4 goes in here 4 times. Wait a minute. The ratios are not equal. 2, 3, 3, 4. So we would say these are not similar. Now, when things are similar and you have ratios which are equal, we can then say the sides are proportional. Proportional means you can make one of these. Then once it's established something similar, you can solve using proportions. The shapes below are similar. Solve for the missing side. Remember, similarity means congruent angles, ratios which are equal. So the first thing you want to do is match up the sides. So watch what I do here. I have two equal sides, squiggle, squiggle, match them up. And then here I have a long side of 42, long side. And then I have a medium side 36 and 6. So first I'm going to check my ratio left to right. 24 and 4. This reduces 1 to 6. Left to right. 1 to 6. So I'm establishing from left to right, my ratio is going to be a 6 to 1 ratio. So to solve, left to right, 42 over x. Cross multiply. X equals 7. Below, the shapes are similar. Similarity means congruent angles, ratios which are equal. So I'm going to establish what my scale factor is. My scale factor from A to B is 3 to 5. Careful, careful. My A is here on the right. My B is here. Now we're not going left to right. So from A to B, it's a 3 to 5 ratio. In whatever direction I start, I must follow. Cross multiply. The key to multiplying is not multiplying. It's factoring. So could you multiply the 3 and 40 and distribute that 5? Sure, if you want to, be my guest. But you could instead, since it's nothing but multiplying on the left, we could factor out the 5. 5 goes in there 8 times, so that makes our number smaller. Now I have 24 on the left, 2x plus 10. What's super great about these problems, it's so easy to check if you're right. So if we say x is 7, this ends up being 2 times 7, which is 14, which of course is 24. So 24 to 40, let's reduce that. 8 goes into both. 8 goes in there 3 times. 8 goes in there 5 times. Oh, looky there. There is our ratio. You do this page on your own. Pause the video. Welcome back. Did you get your red pen, folks? I'm going to be checking for corrections. Hopefully you're correcting and not copying. You're going to see if it's similar. Congruent angles, ratios, equal, scare. So we definitely have the congruent angles going on here. Double, double. Let's check our ratios. 40 long to long. Okay. 8 goes in there 5 times. 8 goes in there 6 times. Short to short. 6 goes in there 5 times. 6 goes in here 6 times. Side to side. 3 goes in here 5 times. 3 goes in here 6 times. So yes, these are similar. Let's check over here. Right, angles are the same. Let's check the ratios. Short to short, that's 25 to 30. It's a 5 to 6 ratio. Long to long, 5 to 6 ratio. So this is also similar. Items below are similar. Use that to find the missing side. I call that X, making a proportion. So I go short to short. I'm going left to right, 24, 28. Long to long, left to right, 30 over X. Key to multiplying is not multiplying. It's factoring. You did not need a calculator here. If you used a calculator, get in the habit of ditching the calculator. Ready? Again, I'll show you how to do. Key to multiplying is not multiplying, it's factoring. So first you ask yourself what the 24 and 28 share in common. That would of course be 4. So 4 goes in here 7 times. 4 goes in here 6 times. 6 goes into 35 times. 7 times 5. X is 35. Going here. Proportion. Ratio. So we match short to short. So that's going to be 15 short to 20 short. And then this is the longest side, and it matches with the 30. So 30 to longest side. Key to multiplying is not multiplying. So I have 15 X 20 times 30. Divide by 15. Goes in there twice. X is 40. Review all the pages and summarize what you believe are the main concepts. Whoops, you had 2 more. Excuse me. Almost there. These are easies. So A to B, 2 to 3, A to B. Cross multiply, I've got 2 times 21 equals 3 and X plus 3. So we're dividing by 3, 7. We get 14 equals X plus 3 minus 3 both sides. And we get X equals 11. Watching the ratio, A to B is 3 to 7. We go left to right, 7 over 3 equals 3x plus 27 over 36. Cross multiply, 7 times 36, 3x plus 27. The key to multiplying is not multiplying, it's factoring. So I'm going to factor out this 3. 3 goes into 36 12 times. It's going to be 84 equals 3x plus 27. X equals 19. There you go, folks. Now, summarize the key concepts from today's lesson.